Hello friends, welcome back. I am Rajnesh and today's session is about Kerberos. So what does Kerberos means and what it is? Kerberos is an authentication protocol. Okay, so it means that when we are trying to authenticate against a particular server or against specific credentials, so we can use this protocol. What's the difference between this and regular PAM login or LDAP based authentication, whether it's using shadow file or LDAP based authentication? If we are talking about any other kind of authentication, the credentials flow through the network. If we are talking about telnet, the data or the credentials are flowing through the network in plain text and they can easily be sniffed. What's the difference when we are using Kerberos? When we are using Kerberos, the passwords never flow through the network. If we are talking about LDAP based authentication, then the credentials are still flowing through the network, but they are in encrypted format. It could be SSHA algorithm, SHA algorithm, crypt algorithm, but the passwords are still flowing through the network. In case you are using TLS or SSL, the credentials are flowing through a SSH tunnel, but they are still flowing through the network. But if we are talking about Kerberos, the credentials or specifically your password never travels across the network. Okay, so this is the authentication protocol that we use to log in into a server or that we use to access a particular service. So it's on trusted hosts. It's for trusted hosts on trusted networks. We used the word trusted hosts because these hosts that are Kerberized need to belong to a particular ream. I'll let you know through the lab what actually the ream is. Ream is actually your domain in terms of Kerberos, where you could have your services, you could have your servers, and you could have your principal users. So these are actually three kind of principals. It could either be a server, a service, or any user. So it's an authentication protocol for trusted hosts on untrusted network. It can be used on untrusted networks because your credentials, specifically your password, never flow through the network. Okay, aims. The first thing is the user's password should never flow through the network, either in encrypted format or unencrypted format. It should never flow through the network. The user's password must never be stored in any form on the client machine. If we are talking about the client machine, the user's password should never be stored. In case it's present, it should immediately be destroyed by the client application that is using it. The third thing is user's password should never be stored in unencrypted format, even in the authentication server database. And yeah, this password is never saved in unencrypted format in the Kerberos database or authentication server database. And the most important thing that Kerberos provides is a single sign on because it makes use of ticket granting tickets and then tickets. So finally, in case we have received a ticket granting ticket once, we can use the ticket granting server to get the tickets and we don't have to specify the password again and again. So it says at the first time when you log in into the server, you receive a ticket granting ticket, and every time you are trying to access a service, that ticket granting ticket will be checked. And if you are allowed access to a particular service, you will never be allowed to enter the same password or the password again. The user is asked to enter the password only once per session. Terms involved. So one is ream, Ream is the same as the domain. For example, if we are talking about labs.local domain, so okay, other thing is ream is case sensitive, and we generally use capital letter or block letters when we are creating a ream. So ream is a collection of principles that belong to the same domain. So it's authentication administrative domain. Principle. Principal means any entry in Kerberos database. It could be a user, it could be a service, or it could be a server. And the format is name slash instance. It could be host slash hostname. For example, it's host slash infra.labs.local at the rate. If we are talking about our environment, the ream will be labs.local in capital letters. It could even include just the name. So if we are talking about the users that we'll be creating, they could be like username at the rate ream. We'll have the thing explained in the lab. Key KDC is key distribution center. So this basically has three components. One is the database where you store the principles. Other is authentication server, which is responsible for authenticating the users, and ticket granting server, which is responsible for providing the tickets. Authentication server is responsible for providing ticket granting tickets, and finally the ticket will be received by ticket granting server. Ticket. So ticket is something which allows you access to a particular service. So client presents this ticket to the application server to demonstrate that yes, I am the right person, I should be allowed access to a particular server. And here ticket is something which you give to the server and say this is my identity. Authentication server is responsible for providing ticket, granting ticket, and authenticating the user. Ticket granting server is responsible for providing the tickets that can be used to access a particular service. An application server is the server that is running a particular service that we want to access. For example, it could be a POP server, it could be an IMAP server, SSH server, which is running a service which is Kerberized. So the objective, if we are talking about the Kerberos environment or a Kerberos stream, is to access the services of the application server. Here is the diagram. Here is the client. Client has his key. Application server or the service has its own key. And key distribution center has its own key. And all these keys are stored in the database in Kerberos. So if we are talking about key distribution center, it has three parts. One is authentication server, which is responsible for the initial authentication. Other is ticket granting server, responsible for granting the tickets. And third part is database, where it stores the principles. If we are talking about the database, any principle associated with the ream has an entry in it. And Kerberos uses symmetric key algorithm. If we are talking about a user XYZ, so when we create a principal, his key is created on the key distribution center, and when user tries to log in into it, user provides its password to log in into it. So if we are talking about any particular service or KDC or any particular user, this Kerberos database has a symmetric key corresponding to all these principles. other part is okay. Uh, I'll let you know later. So let's try to understand how this authentication mechanism works. Suppose early in the morning user first tries to log in into a server. The first thing that happens is user receives a ticket granting ticket from an authentication server. Okay, how does it happen? First thing, I see the login prompt, I enter my username, and my username flows through the network and goes to the authentication server or the KDC, and KDC checks out the identity of the user in this database. In case he finds the identity of this particular user XYZ or RCval in this case, he or the key distribution center fetches out the key corresponding to the user and creates a ticket granting ticket for this user. So ticket granting ticket consists of the username, the client IP from which he is trying to log in, and the KDC name. And these details are then encrypted using the Kerberos or KDC's private key. So ticket granting ticket is now encrypted and it cannot be read by any other service or user because it's encrypted with the private key of KDC. Okay, so there should be some other key that will be used whenever the communication is happening between authentication server and the user. So key distribution center creates a session key. Here is the session key. It creates a session key and then sends the details to the client. So these details will include a ticket granting ticket which is encrypted by KDC's private key, and second part is session key, and altogether both the two things are then encrypted with the user's private key. So now this TGT and session flows through the network and reaches the user. User, in case he has his private key, he will be able to decrypt it and will be able to receive the session key. In case user doesn't know his credentials or user is entering the wrong password, he will not be able to decrypt it, or the fake user will never be able to access it. In case he enters the right credentials, he'll be able to open the packet and he'll be able to isolate this session key and ticket granting ticket which is encrypted. So user cannot read ticket granting ticket. Now this is the first part that happens as soon as user gets a ticket granting ticket or first login into the server. Now if this user tries to access the service of the application server, it could be SSH service, so it needs to authenticate itself to the application server. How does it happen? Okay, now user has proved its identity to the key distribution center, and he has received a ticket granting ticket which is encrypted and cannot be read by the user. This ticket granting ticket is valid for a particular interval of time. It could be 24 hours, that's specified in TGT, and you can modify that while configuring KDC. Okay, now this user says to the KDC, I want to access the SSH service on this application server. Now, to make this request, what user does is first user creates an authenticator. So user authenticator will include the username, the IP address of this machine, and the timestamp when I am requesting this service. And this will then be encrypted with the session key. And the second part that user is going to send to the ticket granting ticket is TGT, and altogether it will be encrypted with a session key. Now it reaches ticket granting ticket and encrypted authenticator encrypted with the session key reaches the ticket granting server. Now, ticket granting server part of the key distribution center, as it has the session key that was provided to the user also, it decrypts this packet. It fetches out the authenticator, it fetches out the ticket granting ticket. Now, as this KDC has the private key for ticket granting ticket, it opens and reads TGT and matches the details with the authenticator. So authenticator was created by the client, including client's IP and username and timestamp. So it matches the details, username and IP address. In case they match, it is fine, because TGT is such a thing that cannot be tampered, because the private key is known only to key distribution center. So after it has checked the identity and it makes sure that the user has access to the service, it creates a ticket. This ticket granting server creates a ticket which will consist of the details: user, IP address, and the service that client is trying to access, or in case he is allowed access for that. So it creates a ticket. The ticket is now signed with the private key of this application server. So once again, the client will not be able to read this ticket. This ticket is supposed to be read only by the application server. So the ticket is encrypted with the key of this application server's service. Okay. The other part that this ticket granting server is going to send to the client is session key, which will serve as a session key for between the client and the application server. And so it has created two things: a ticket encrypted with the private key of application server, and the session key for client application session, and both of them will then be combined and encrypted with the session key of client and Kerberos session. So as soon as it reaches the client, client has this key, it decrypts, and uh, it has the client application session key and the ticket. Ticket is still encrypted, which it cannot read. So client is again going to create an authenticator, and the authenticator will again be client, its IP address and timestamp, but right now it will be encrypted with the session key of client and application server. So it will create an authenticator, and it already has the ticket which is encrypted. So both of them will be combined and will be encrypted with this session key and will be sent to the application server. And okay, the ticket the ticket part will be sent will actually uh, not be encrypted because it's already encrypted. So as soon as application server receives it, application server has the private key, it will decrypt the ticket and it will have the session key of itself. Now the application server has the session key, and now it will decrypt the authenticator and make sure that client has access to it. Now the client has access to the client app session key, and application server also has. And authenticator has reached to the application server, ticket is reached to the application server. Application makes server make sure that he has access to it and provides access to the client. Okay, so if we are talking about the entire flow of data, the data was never sent in plain text except the username. So password never traveled in plain text. Okay, so coming on to the lab now. This is a server, or cancel it. This is our client. Let me open a new terminal. SSH 192.168.100.254, which is our infra. One 192.168.100 dot 11 as a client, as a root. Okay, okay, here is the client and here is server. So the first thing is, how do we configure and install Kerberos server? Let me mount the CD drive. Search KRB5 server. So let me install Kerberos 5 server as of now. And to manage it, I'll also be needing KRB5 workstation. Okay, so okay, first thing we need to do is we need to define a ream for it, and we'll define it as our domain, which is labs.local. So the ream is going to be in capital letter, labs.local. Let me configure the client configuration before it. krb5.conf is the client configuration whenever I'm trying to interact with the Kerberos. So default ream, let's replace it by labs.local. DNS lookup ream and lookup KDC. As of now, let's leave them as false because we have not yet configured DNS for service-based DNS service-based records or TXT records. So ream labs.local says KDC is infra.labs.local and admin server is again infra.labs.local. Domain ream for this domain labs.local goes to the stream labs.local, and this domain again goes to the ream labs.local. Okay, so the generic krb5.conf or Kerberos client end configuration is done. Let's make sure that the resolution is working fine. Yum install bind utils, because I was not able to see nslookup. Infra.labs.local. Okay, the resolution is fine and my IP address is the same one. Okay, so first thing I need to create the database for Kerberos. So krb5 util. Okay, I'm still missing something. Search krb5. So krb5 server we have installed. Other thing that we are missing is, okay, yum install yum utils, because it is going to provide me a command repo query. I'm not sure which package provides kdb5 utils. Repo query -f star kdb5 utils. I think it should be krb5 libs kdb5 dash util krb5 server. Okay, okay, kdb5 util is there. You can see the manual, and our objective is kdb5 util to create -s for stash file. Stash file is the file that we create so that Kerberos database makes use of this file when restarting and doesn't ask us for the password. And the other option is ream, which will be labs.local. Okay, now it asks you for the master key name, which is Kerberos/master k/m, and the master password, let's give it master at 123. Master at 123. Okay, okay, so Kerberos database has been created, and it will be created at var Kerberos krb5 kdc. Okay, one more thing that we have to look into is kadm5.acl. It says what access is provided to which users. If we are talking about */admin, what is the access? Our ream is labs.local. So star says all access. So anyone under /admin will have full access to the Kerberos database. Okay. kdc.conf, what does it says? The ream that we have to use is labs.local. ACL file is fine. Admin key tab is fine. Okay. Now let me restart the KDC database. And let me restart kadmin, and let me switch on these services. and I can admin. Okay, it says client not found when I'm trying to authenticate as root slash admin. The reason is it's not yet created, so I can connect to kadmin as kadmin.local because this is present on the same server. Now here is the command that I use to list all the principals in it. So here I can see this is the master user that is present, kadmin slash admin, kadmin slash change password, and kadmin slash and this host name at the rate ream for ticket granting ticket. This is present. So these are the principles which are right now present. Let's try to add a new principal which will be root slash admin. Add prince is the command, root slash admin at the late at labs.local. Let me give it the password root at 123. So this principle is now created. The other thing that I need to create, let's create it for a particular service or for a particular host. Let's say it's infra.labs.local. So this was the principle that we created for a user, so any user can remind of the password. We have entered the password and user will be able to enter it. I'll show you. The second part is when we are creating it for a particular host. If we are creating it for a particular host, it can use a random password. So add prince minus rand any random key, and we are creating it for host slash infra.labs.local at labs.local. So it has created an entry for the principal. Now the second part that we have to do is we have to download this principal to its key tab. That can be done through kt-add, and minus k stands for the key tab where it's to be loaded, krb5 dot key tab, and which is the principal. So the principal is host slash infra dot labs dot local at the rate labs dot local. So I have added the principal corresponding to this host in slash etc krb5.kdc. This is the default file where it is. Okay, this is the default key tab file for any system. So I just quit out of it. I just restart SSHD, or before that I'll show you one thing. If I type the command k in it, okay, let me create a principal for myself. Here I cannot see any user like rcval. Okay, so I just create a user, so it doesn't have any password. The second part I'll do is kadmin, and I connect to it. I provided the root password and I add a principal for this user. rcwallet123. So now you can see that this password rcwallet123 is corresponding to the Kerberos user. I quit out of it. Slash etc sshd underscore config GSS API, General Security Services API, is a protocol that could be used or GSS API authentication. In case it's set to yes, it supports Kerberos authentication. So let's just restart SSHD. One more thing that we have to do is we have to tell the server authconfig TUI user information, let it be local or LDAP, whichever you want. But if you are talking about authentication, use Kerberos. And I click on next. It says PAM underscore KDB5 pack KRB5 package is missing. So let's go back and install this package. Yum install PAM underscore KRB5. Now this is the part that we are doing in infra server. Authconfig TUI. Authentication, it's a regular, or in case it's already authenticating against LDAP, that is fine. But the authentication part will be using Kerberos. Next, ream is labs.local. KDC is infra.labs.local. Fine. Resolution doesn't look for it. Click on it. Okay. Now let's just restart SSHD. Okay. Now, key list. We don't have any kind of credentials in it. Let me open one more session. One 192.168.100.254. Or let's leave it as of now. I'll say first part that I do is kinit rcval, which says try to get a ticket granting ticket from the authentication server or key distribution center. Password is rcval at 123. Now if I type klist, here I can see that Kerberos server or the KDC has provided me a ticket granting Kerberos ticket granting ticket, which expires on today's 11th Jan 2013, and it expires on 12th Jan. So Kerberos TGT is going to be available for the next 24 hours, and we can get it renewed before it. Okay. Now if I try to SSH to this server, okay, SSH is not there. Let's install open SSH client for it. Sorry, it's open SSH clients. Now first thing is we already have a ticket granting ticket, and now I try to SSH to this server, and here you can see I am into this server without even entering the password. The reason was that I already received a ticket granting ticket from the Kerberos server. Now when I tried to access the service SSH, I was able to access it directly because first of all my SSHD underscore config SSH D underscore config says Kerberos is supported. GSS API authentication, yes. So Kerberos is supported. And second thing is this kadmin.local list prints. Second thing is that I have a host principal corresponding to this server. Okay. This is how we log in into the same server as the Kerberos with Kerberos credentials. Let me try to log in from the client server now. First thing that we need to do is, if we are talking about the Kerberos ream, all the clients are going to share the same krb5.conf /etc krb5.conf, and I send it to client.labs.local. Okay, I was not able to connect it. And let's look up yum install DNS utils or named utils. Okay. I'll have to configure a repository for it. So better is I share the same file. I just delete it and use the same Kerberos file from this infra server. Copy and paste it. Okay, now if I type the command kadmin, it's not there. First thing that I need to do is yum install krb5 workstation on any Kerberos client that I'll be using. And in case I am authenticating this machine against Kerberos authentication, I'll have to add pam underscore krb5 package. Okay, mount dev cd-rom to media. So I have these packages installed on it. Cat etc passwd. There is no such user as rsiva. Let me create a user. Okay, so I've created a user, but without any password. Password will be fetched from this Kerberos server. Okay, now I'll configure this client to use okay, other part is su minus rsival. I'll show you how it works. Tail minus f var log messages var log krb5 kdc.log var log kadmin.log. Okay, the first part, when a client logins into a particular server, he'll do a kinit. Resource temporarily unavailable while getting credentials. The reason is the firewall. Let me make sure whether the ports are open or not, or we'll have to open them. Copy, ping. Okay, NS lookup is also failing. Name server 170 192.168.100.254. Ping infra.labs.local. Okay, resolution is fine. Now let's talk about the ports, whether they are open or not. /etc services. Kerberos is 88 TCP and UDP. Let me open them. IP tables -I input minus S, our network 192.168.100.0/24, minus P, TCP minus minus D port 88, minus J, accept. Okay, other is UDP port. Okay, and then service IP tables save. Okay, su minus rcval, let's become rcval and try to get a ticket granting ticket. Okay, I wanted to show you the logs while it's happening. So while using kinit, I say to the KDC, please provide me a ticket granting ticket. I provided a password. Okay, I just entered username and KDC received an information for authentication server request from this IP address. I just entered the password and okay, K list. Now it received a request and replied me with the ticket granting ticket that I can see, and here it is, and it is it'll work for the next 24 hours. Okay, now I can use this ticket to log in into the server, which is infra.labs.local. Okay, I need to install the package. Open SSH clients. Let me become rcval and let me see if I have the key. Yes, I already have. Now I tried to log in into this infra.labs.local and the request came to the KRB5 KDC, and the request was for ticket granting server, that please provide me a ticket, and ticket granting server replied me with the ticket which is encrypted for the service and which was sent to the this client machine created an authenticator and used the session key which was provided by the infra server, and it was sent back to the infra server because in the next stage it is working as an SSH or the application server. So that is the reason. Okay, so it received the ticket, it decrypted it, make sure that user has access to it, and allowed him access. Okay, this is how a Kerberos authentication works. Let me know if there are still any concerns. Okay, uh, let me tell you one more thing. What in case you want this client server to authenticate against Kerberos? I'll have to use authconfig TUI. User information can be from any database, but user should be present, and authentication will be use Kerberos. Labs.local KDC ream is fine. Click on OK. Okay. Now, if I try to log in into this client machine 192.168.100.11, Okay, so here you can see I am able to log in into this machine, and if I just type klist command, here I have received the Kerberos ticket granting ticket. Now if I try to log in into any server, I'll be able to log in into that server or any kind of service for which ticket or the KDC allows me to have access to it. So this is how your single sign-on or your Kerberos Ream authentication works. I hope I am able to make you understand the concepts. Thanks for viewing the video. Have a good day.